Hey college physics students, welcome to our first lab. Um, it's going to be graphing exercise. You're going to have to make graphs of data in this lab for this summer. And I want to get everybody on the same page, see what a graph entails, what I expect, and what your graph should look like. So here's what you do to get started working on lab. You go to course content in your Blackboard page, and there'll be a folder there called Lab. You click on it. Here's lab number 1. So you're going to click on that. It has a document attached to it, a Word document. And so we're going to download that and work on that. We're going to fill in that Word document with our information and whatever's required. And then we're going to convert it to a PDF and come back here and submit it. Browse my computer, you find your PDF and submit it. So we're going to come back here and submit it. So we get started by clicking on the Word document. It asks me if I want to save it, or I'm going to save it onto my desktop. So I'm just saving it on my desktop so I can find it. It's called Introduction Graphing 2. All right. So you can't see my desktop because it's on a different monitor here. So now I'm going to open it, drag it over to this monitor. Okay, introduction and graphing. All right, so name. When you type in here, anything you type into your lab report, I want it to be in a different colored font so I can pick it up. So I'm going to choose blue today, and I'll do theme this summer. And we've been using in physics lab for about the last 20 or 30 years or so. We've been using a software called Graphical Analysis. It's designed to make scientific type graphs. You can use Excel or Google Docs or whatever the Apple equivalent is. But making the kind of graph that you need for this class is pretty much of a chore in those other software things. And graphical analysis, good program. It loves to make graphs, and it's pretty intuitive. And it doesn't do as much stuff as Excel does, of course, because it's designed primarily for just making scientific type XY scatter graphs. And the fact that it doesn't do as much as Excel is really good, because it does its limited stuff much better. Is now open source and it's free. So you get it at this link here. So I'll just click on it and we'll go to that link. Here it is here, graphical analysis. You can download it for Windows or Mac OS. That's what you want to use. I don't have either of those operating systems. I use Linux. It's also for Android. I guess you can get it on your cell phone. So you got to get that program first. I'm not going to download it here because I'm working on a Linux machine. I did download it to my tablet, so I'll be able to open it on my tablet. I haven't used it before, so this is going to be the first time I've ever used this version of it. We'll see if it's as good as the original. So you get that, and here's a plot the following data. So here's a little example just to get us started. Open graphical analysis, choose manual entry, and enter the data. This data here. Change the column labels to time and velocity with seconds and meters per second units, And so it tells us how to get started. And whenever you're asked to graph something versus something else, they're always telling you what is y versus x, what goes on the vertical axis versus what goes on the horizontal axis. And we have to include units in everything here. That's the difference between physics and your math classes when you're making graphs. Nothing has units hardly in math class. So we need units in everything. So here's just some simple questions. Does time or velocity go on the x-axis? Well, I think time goes on the x-axis here. Oh, go on the y-axis. Excuse me, I didn't read that carefully. I guess velocity here. So I'm going to type velocity. That's my answer in blue. What's the slope of this line? Well, that's the rise over the run. So if I just take these first 2 points, take 13.1 minus 3.3, that's 9.8, and 1 minus 0 is 1. So the slope of this line would be 9.8. Once again, put it in blue. Would be 9.8. But now our slope's going to have units. It's going to be meters per second divided by seconds. So that's meters per second divided by seconds. Meters per second per second. So this is a graph of a moving object here. This is how fast it's going in the right-hand column and what time it is in the left-hand column. What's the physical meaning of... Okay, I'm going to let you think about these things. And now I'm going to make a graph of this data. So that might help me answer some of these questions. So what do I do? Oh, well, I'm going to have to do this on my tablet, which is kind of a pain. You'd be able to do it on your computer. And so let me find graphical analysis. Here it is right here. Graphical. Looks like it's called. So I'll type that. It's starting up. I want to do manual entry, so you're always going to be doing manual entry. You can hook sensors up to this and use it in a highly technical laboratory situation. So now I guess I just click on here, maybe double click. Yeah, there we go. Get a keyboard. And so now I got to look at my data. I guess I'm going to take this and move it over to one of my other monitors so I can look at the data while I type it in here. So 0, 3.3 is the 3.3. I'm just getting this off the lab write-up. 1, 13.1. See, look at this, making a graph already. See, it's graphed these 2 points. This program just loves to graph. So I guess I could even use a microphone if I had one, I guess. And I could speak the data. And then I'm going to go to and 22.9. There's my 3 points. It's already made a graph with 3 points in it. Cool. And then 3, 32.7. And then 4, 42.5. And 5, 52.3. All right. Now I'm going to go up here to these 3 dots for the x-axis and go to column options. And I'm going to give this a new name. I'm going to call this time. And it's asking me for units. And I'm going to do meters. Nope. seconds, S, and say OK. So now it's called that time. Then I'm going to click on this Y, go to column options, and that's going to be velocity. And that units will be meters per second. Meters per second. All right. Look at, there's our graph. 1, 2, 3, there's our 5 points. Oh, it's using scientific notation. I must have clicked that. Column options. See, I'm not going to use science. We won't need scientific notation in our graphs usually. Numbers would be normal size. Okay, so it made the graph. It labeled the X and Y axes. So if you're using Excel or something, the axes have to be labeled with units. And now down here, this little picture of a graph down here at the lower left, that must be the graph options. So I'm going to click on that and edit graph options. I'm going to give a title. Your graphs, every graph has to have a title. Velocity versus time. All right. And then it's got some other, excuse me. You can change the x-axis range and the y-axis range. The defaults will often be good enough. So here's my title. X and Y axes are labeled. All done pretty quickly. Excel, not so much. All right, now, here's the last important step, an essential thing for your graph, is your graph is going to be usually data that's hopefully falling on a straight line. We always try to graph straight lines in this class. Y equals mx plus b. Everybody's familiar with the standard form for a straight line, and we make use of that standard form frequently. So I want to find a best fit of the equation of a line that goes through these points, and we're almost always going to have to do that for our lab exercises. So I'm going to go over here and select these points, and then I'm going to try to find, in Excel this is called a trend line, and you'd have to look for trend line. Here I'm going to say apply curve fit. And so here's a linear curve fit. You can do other possible things. We'll stick with linear ones and just click apply. And look, we get this little box here. Very nice. Y equals mx plus b. There's our familiar form for a straight line. It's telling me that the line that goes through these points that I've entered has a slope of 9.8 and a y-intercept of 3.3. This is not quite as good as the version we used back in the physics lab because in the version we used back in the physics lab, it gives you the units of the slope. It would say meters per second, and the y-intercept would have units of meters per second because it's on the y-axis. This r is a number between -1 and 1. A number -1 or 1 means that you have a very good fit. Your data is falling very close to a straight line. If you get a number around 0, it probably means that there's something wrong because that means that your data is not falling on a straight line. So that's it. So right now, so what's here? They're asking the y-intercept. What does the, okay, state the equation of the line, define all the variables in the units. So you get that off of the graph. And then for full credit, any graph has to include a title, axes label, a linear fit to the data, and an equation of the linear fit on the graph. All those things are possible in to do in Excel or Google Docs. if you want to hack around in those programs for a while. Now, insert your graph here. So you just need to cut and paste this. If you were, I'm not. This is my tablet, and I've got my computer here, so I can't really just copy and paste this because there are two different devices. So to get around that, just for me, I'm going to take a screenshot of it. I'll just take a screenshot of the graph here. Copy it to the clipboard. And then insert it into my, insert it into my document. I covered up a bunch of stuff here. And there we go. So I finished the first part of this. Plotting a linear relationship out of nonlinear data. So this is another example. Here they want me to enter in this data. I might be able to. I can't cut and paste. You'll be able to just cut and paste this data into graphical analysis if you have graphical analysis running on the same machine. And then if you, this is not going to be linear data. When you look at this graph, you're going to see a parabola. And so a curved kind of graph. So we need, in order to get a linear graph, we need to, let me grab this over here. So I got this, here I pasted in my graph. All right. Then plotting a linear relationship out of nonlinear data. So here's another example. It's going to lead you through step by step here. You would be able to cut and paste this data directly into graphical analysis. I can't do that because I'm using graphical analysis on a different device than my computer. But you can do that. And then it teaches you how to square the time column. So when you do square the time column and change your graph to position versus time squared, it turns out to be a straight line. The slope of that straight line is 1/2 the acceleration. That allows you to take the slope that you get there and calculate the acceleration. So then it asks you to, you don't have to, that just leads you through an example. It doesn't ask you to display that graph. Then it asks you to do the same thing for this set of data. Make a graph of distance versus time squared. And you take that graph and you paste it here and calculate the acceleration from the data just like in the example. Okay, that gets you done with the first lab. Here's the acceleration that you're going to get from the fit of this curve. And now, so first save your work. So I'm going to do a save as. And I'm going to do introduction. I'll just put my name here, Burkhart. And save it on the desktop. Then I'm going to export this to PDF. So whatever word processing program you're using should have an export as PDF. So I'm going to export this as a PDF. I'm saving the Word document in case I want to go back and correct anything. So it's going to save it with the same name. Then I'm going to close this. And I'm going to minimize this. All right, so now I've got my work saved as a PDF. I go back to Lab. Go back to Lab 1. So here I'm going to attach a file. And I want to attach a PDF file. Blackboard has difficulty opening any other kind of file. I have to go through and grade this Blackboard has to open it up, and I have to grade it. So I need a PDF. So I'm going to go to the desktop and look for my Introduction Burkhardt.pdf. There it is right there. So it's going to attach this file and submit. It didn't submit it because I'm just previewing this assignment. I'm not viewing it as a student. So you should get a positive result here, saying that your assignment has been accepted and you've turned it in. And that's how it's going to go. So once again, be patient. Expect to spend a lot of time on lab. Don't try to rush through things. Just try to work through them. And try to get high scores in lab. I think it's quite easy to have 100% average at the end of the semester for lab. So it can help your score, help your final score in this class quite a bit. It's worth 20% of your grade. So that's it. Good luck.